right, here we are in the last unit of Financial Math 2, and we're in the first chapter, Interpreting Scatterplots. Our objectives for today: I will graph bivariate data, I will interpret trends based on scatterplots, I will draw lines and curves of best fit. So let's get started. Here we've got our key terms for this particular chapter. Make sure that you review these and are in full understanding of them before moving on with the video. Okay, example 1. Rachel runs a concession stand at the park where she sells water bottles. She keeps a list of these each day of the high temperature and number of water bottles she sells. Rachel's looking for trends that relate to the daily high temperature to the number of water bottles she sells. She thinks that the two variables might be related and she wants to investigate the trends. She's going to use a scatter plot to do that, and below is a list of all of her data. Now, some things to understand here. Let's just take this one. Our X term is the temperature. Whereas the Y term is the number of water bottles sold. And we're going to go ahead and enter all of this data into a calculator. Now, I did find an online emulator. It works pretty good. Sometimes I get a little snag here or there, but we're going to see what we can do with it. I've already gone ahead and entered all of the information in there, so I'm going to have you press pause in just a moment while you enter the data and get caught up. So where we're going to go to is, if you look here, you've got your second button, you've got your alpha button. Those are yellow and green. You're going to go 2 over from that alpha button, and you're going to hit your stat button. And when you hit your stat button, it should come up like this. You're right where you need to be. It's at edit and edit number 1, so you're just going to hit enter. And you can see here you have a list 1 and a list 2. That's what your L1 and L2 represent. Under L1, you'll notice, if you look at the variables, all of my X values. So here I have 65, 71, 79, 80, 86, 86, 91 are all the things that are listed here on this part of the calculator. When I go over to list 2, I've got all of my Y values. So the 102, the 133, the 144, 161, 191, 207, 235, 237, and 243. So go ahead and take just a quick moment, press pause, get these entered, and then we'll go on to our next step. Okay, hopefully you've got those entered. And again, I'm going to strongly recommend, make sure you're doing this, because the problem is if you're not going to be familiar with entering them in, and you're going to really struggle on the quizzes and tests. Okay, next thing you're going to do is hit your second button, which is that yellow button, and then you're going to come up here and hit the Y equals button. And you can see here where I've got plot 1 is on. You need to make sure that yours is on. And so in order to do that, you see that the 1 is highlighted here. You're just going to hit enter. And you can see that you hit enter, it can move it from off to on. So you're going to toggle where it's flashing on the on and hit enter. And then you're going to go ahead and go over to your window next. Now your window, that's just this particular window right here. It wants to know, where do you want your X and Y values? Where do you want me to focus on this potentially huge graph? So what we're going to do is, you notice the lowest X term is 65, so I'm going to put 50. I want to go a little bit below my lowest number. My highest X number was 100, so I'm going to go to 120 for my Y, or my X maximum. I'm going to leave the scale at 1 for right now. The Y minimum. Well, the lowest Y is 102, so I'm going to put 90. Just going again a little bit below the lowest. And my highest Y is 243, so I'm going to go just a little above it and go to 250. And now we're ready to graph. And you're going to go ahead and hit your graph button, And that's hopefully what you see. Now, if you don't, I'd recommend that you go back, check your list, check your plot, and check your window, and make sure all have been set to the areas that I've asked you to set them at. And that's what our scatter plot looks for this particular question. All right, moving on. It says here that if the temperature reaches 68 degrees Fahrenheit tomorrow, about how many water bottles do you predict will be sold? Well, here's the thing. Now that we have our scatter plot, we can actually create a line of best fit, which ends up being that slope that we're so used to working with. And believe it or not, we've already done all the work. We're just going to have the calculator do the rest for us. So again, you're going to click on that stat button. That's where we started originally. But instead of going to edit, you're going to go one over to where it says calc. So you see now CALC is what's highlighted on your screen. You're going to go down until you get to number 4 where it says linear regression. And it's in y equals ax plus b, or mx plus b is what we're more familiar with. And you're going to go ahead and hit enter 2 times. And you should get something that looks like this, where a is, and I'm going to go ahead and round, a is 4.44, and b is negative 187.67. Now that we have that, we're going to go ahead and create our equation of y equals 4.44x minus 187.67. Now the awesome part about this, now, remember x is my temperature. I can give you any temperature. You're going to be able to plug it in and determine approximately how many water bottles are sold. Respectively, I could also give you any number of water bottles sold and tell you to tell me approximately where the temperature was. But in this case, it gives us a degrees, so it's y equals 4.44 times 68 degrees minus the 187.67. Now when I plug all that in, I get about 114 bottles. Now, I'll give you, just so you know, linear regression, it is probably the lowest form of what we could have done there. There are other things that we could have done that would have gotten us more exact, but we're talking about the difference of maybe 3 to 4 bottles. So it's pretty accurate here. We're looking at about anywhere really from about 114 bottles to 118 bottles. All right, example 2. Rachel wants to interpret the trend shown in the scatter plot. What do you notice about the relationship in the temperature and the water bottle sales? And is there an explanatory variable, and is there a response variable? Well, if we go back to our calculator and click on our graph, we can clearly see here that as the temperature rises, remember it's here on that horizontal axis, that the number of water bottles on that vertical axis are being sold. So we can see the line that is being created is going up. As values of x are going up, values of y are also going up. So as x increases, y increases, which means that there is a positive correlation. Further, it seems like that as the temperature rises, the number of water bottles sold increases. Therefore, it seems that the temperature caused an increase in water bottles sold. Therefore, looking at this, the explanatory variable, it's explaining why something has happened. The explanatory variable is the temperature. And you'd ask, well, what happens when the temperature changes? The number of water bottles sold changes. So the response variable, when the temperature changes, the number of water bottles sold changes. So it's the response variable. So yes, there is a definite correlation. The explanatory variable is my temperature. My response variable is the number of bottles sold. All right, please press pause. Go ahead and solve this. When you're ready, come back and we'll work it together. Okay, let's look at this here. A local coffee shop sells hot chocolate. The manager keeps track of the temperature for the entire year. A scatter plot is graphed with temperature on the horizontal axis of hot chocolate sales and the vertical axis. So temperature is on the horizontal. Here's your temperature. And over here is your hot chocolate sales. Okay, it says, do you think the scatter plot shows a positive or negative correlation? So let's go ahead and just put in some general numbers and let's think this through. So, if you were to think about it, if the temperature is colder or lower, am I going to sell more or less hot chocolate? And logically, I would say that when the temperature is colder, more people want to drink those hot drinks. But as it gets warmer, people start looking at other things like iced tea, ice cream, and good stuff like that. So what we see is that as the temperature increases, or as X increases, what's happening to Y? And you see that Y is decreasing, which means that there is a negative correlation. So just like with the water example, the higher the temperature got, the more water bottles were sold. Here, the higher the temperature got, the less hot chocolate was sold. And so there is a negative correlation. There is causation. The cause, or the causation again, is the temperature. And the response is lower hot chocolate sales.